Problem number 4 says, Shayla spends 3 hours studying for each quiz in her math class. She also spends 2 hours working on a project. The table lists the amount of time she spends studying for quizzes or working on a project for class. So she studies 3 hours for each quiz in her math class. What does that maybe, let's think about that. So she studies 3 hours. 3 hours for each quiz. So let's just, before I try to plug some numbers in here, let's just talk. If I have 2 quizzes, how many hours would I study?
6.
If I had 3 quizzes, how many hours would I study?
9.
So what am I doing with the variable quizzes? I'm doing something to that, and that tells me the amount of time.
You're multiplying by 2 times 3. You're split.
Right, I could say t equals 3q or y equals 3x, right? Does that make sense?
Y equals 3x plus 2.
Well, it might. Yeah, you're right. There might be some other stuff here that we need to think about. So let's go back and look. Oh, wait. She also spends 2 hours working on a project. Now, is that for every quiz or just
one?
Just one. So we have to make some assumptions, right? We have to make some assumptions. You could read this and think that for every quiz she spends 3 hours studying for, and for every project she spends 2 hours working on it. Or you could think that she has a project and she has to study for 3 hours for each quiz. Those will give you different equations. You could think for every quiz she works for 2 hours on a separate project. The table of values are going to kind of help us out to determine what that would look like. So what I'm going to do is, if we look at our delta x, what am I doing to get from 3 to 4?
Adding 1.
Adding 1. And get from 4 to 5, what are we doing? So let's assume that this number is what? 2. How'd you get that?
Subtracted 1.
Subtracted 1. And then this one would be 1. And that allows us to continue to add 1. So what's delta x?
1.
Delta x is 1. We change a positive 1 each time. Now look at this. What's delta y? What's the change in y? Yeah, we're adding 3, positive 3. So if this is linear, then the slope would be 3 over 1, which would be 3.
But it's not.
Well, we don't know. We got to figure it out. So now I'm going to say that f of x is equal to, we know that there's a constant rate of change of 3. Or we're assuming that. It may or may not. Let's think. So if that's the case, then I have 3 times x plus b. We don't know what it is yet. We could guess, though, but let's see. If I were to evaluate f of 1, that would mean 3 times the quantity 1 plus some value. But what is the y value associated with an x value of 1?
5.
What I mean is, like, when I plug 1 in, I should get 5, right?
Yeah.
So what's 3 times 1?
3.
3. So what do I add to it?
2.
2. So now what that means is b might equal 2.
Wait.
Yeah, because it's 2 hours.
You was confusing. So you saying, like, we do 3 times 1, obviously it's 3. When you take whatever equals that number, so like whatever equals 5, and 3 plus 2 is 5.
Right, we think. Now how could I double check that, though?
Okay.
How could I double check that to make sure that the y-intercept is 2? Let's try this with f of 2. Now, I'm going to plug some stuff in, but what does that have to equal when we're done?
8.
Yeah.
8, right? So if that's the case, now where I'm getting that from is this is the point 1 comma 5, right? This is, and then this one over here is the point 2 comma 8. So whatever our equation is, it has to work for both those. we're making a lot of assumptions, okay? We don't know for sure, but we're going to test it and see. So now, we're assuming that 3 times 2 is what?
6.
6 plus
Two.
2. Does that give me 8?
Yeah.
Yeah. So we have a reasonable assurance to believe that our equation is 3x plus 2. So now let's do that. If I wanted to find f of 3, I would get 3 times 3 plus 2. What's 3 times 3? Plus 2 is 11. Now what do you notice about that 11?
It's when you add 3.
Yep, if I add 3 to 8, I get 11. Does that make sense?
Yeah.
Okay, so now let's do the next one. F of 4 is equal to 3 times 4 plus 2. What's 3 times 4?
12.
What is 12 plus 2?
14.
Hey, look, I'm adding 3, aren't I?
Yeah.
So we've got 14. What do you think the next number is?
17.
17. That's right, too, because 5 times 3 is
15 plus 2.
plus 2 is 17. So good. So now let's graph these bad boys. So let's zoom in.
Oh yeah.
I know you guys are just as pumped as I am. So let's do this. So we've got 1 comma 5. So here's 1, and then 5 would be here. By the way, if our equation is 3x plus 2, what's the y-intercept?
The y-intercept is 2.
2. Is this a linear function?
Yeah.
Yeah. So I should be able to draw a straight line through those dots and get the rest of the points on the line. But let's go ahead and plot them all. The next point is 2 comma 8. Hey, that falls on the line, doesn't it?
Yes.
So I've got, let's write this down before I forget. 1 comma 5, 2 comma 8, 3 comma 11. Oh, no. This is 2 comma 8. Oh man, I screwed that all up. This is 2 comma 8.
Wait, what?
Yeah, continue.
Yeah, I made a boo-boo. 1 comma 5. And then this is just, what's that point there?
Hey, boo-boo.
0 and 2.
0 comma 2. Right? So now let's plot the rest of them. I've got to have 3 comma 11. So I'm going to go, wait, can I use, let me ask you this. This might help too. Let's practice a bunch of stuff. Slope is delta y over delta x. What was delta y again?
2.
No.
Wait, where are you talking about?
Delta y. The change in y. What do we add to get the next?
Yeah, it was 3 over 1.
It was 3, and then delta x was 1. So my slope is
3.
3. Now I know that because we said that our slope is 3, right?
Yes.
So then that means I'm going to go up 3 over 1. So if I go up 1, 2, 3 over 1, am I still on the line?
Yeah.
If I go up 1, 2, 3 over 1, am I still on the line?
Yeah.
Yep, let's try that one more time. Up 1, 2, 3 over 1, am I still on the line?
Yes.
Those are the points, though.
Those are all the points. So I'm going to draw my little line. Skirt, skirt. All right. Does that make sense?
Yeah.
So this is the equation. F of x is equal to 3x plus 2. Now based on that equation, what assumption are we making about this 2 hours working?
That is only one part. Yeah, only one part.
Yeah, she only does it once. All right? So she's got, it's the end of the semester, she has 3 quizzes and 1 project, so she's going to take 2 hours to study for, or to finish her project, and then 3 hours per quiz. Does that make sense?